Hello everyone, this is part 2 of our review for exam 3. We'll just pick up where we left off. We're looking at a review questions on using undetermined coefficients to state the form for y sub p, not evaluating the coefficients at all. So our standard procedure, associated homogeneous. You could actually skip this step and go right to the characteristic equation if you like, but I'll be formal. So we got r squared plus 25 is 0. I'll choose to isolate the r squared. Square root gives us plus or minus 5i. Okay, so complex conjugate roots, recall the form then for y sub c. It's going to be e to the ax, but a is 0. Because it's of the form a plus or minus bi, and then times c1 cosine bx, b is 5, so cosine 5x, plus c2 sine of 5x as well. Let's get rid of the e to the 0x, so just c1 cosine 5x plus c2 sine of 5x. Okay, and then if we look at our function, our guess is going to be for cosine 5x, we have to include both. Remember, if there's sine or cosine, you have to include both no matter what. So we'll consider choosing a cosine 5x plus b sine of 5x, but then when we make our comparison between y sub c and y sub p, we see there are duplications, and multiplying by the least power of x so that there aren't any, looks like we're going to get away with just multiplying by x. So therefore we take our y sub p to be equal to, and you could write it any way you want. You could write it as x times a cosine 5x plus b sine 5x, or if you prefer, you could distribute the x. So ax cosine 5x plus bx sine of 5x, but that's all you would need to do for this particular type of question. Okay, so then one more example of this. Same procedure, associated homogeneous. We get the sixth derivative of y minus the fourth derivative of y equaling 0. Characteristic equation, r to the sixth minus r to the fourth is 0. Okay, factoring that, we have greatest common factors, r to the fourth, then r squared minus 1 is left, and I think I'll factor the r squared minus 1 as r minus 1, r plus 1, and so r to the fourth is 0, r minus 1 is 0, r plus 1 is 0. Of course I didn't really need to write that. You could just jump to r equals 0, but this is important here. Multiplicity of 4. Here r is 1, and r is negative 1. Okay, so coming from the multiplicity of 4, y sub c is c1 plus c2x plus c3x squared plus c4 plus c3x squared plus c4x cubed, all times e to the 0x. And then left off with c4, so let me call this c5, e to the 1x, coming from the real root of 1, and then plus c6 e to the negative 1x. Alright, so let's clean this up. And so y sub c would be c1 plus c2x plus c3 x squared plus c4 x cubed plus c5 e to the x plus c6 e to the negative x. Alright, so then we make our guess. And our guess, well, first off, for e to the x, we'd have to have an a e to the x. But then plus, for the polynomial part, x cubed minus 1. Okay, again, you could use your little cheat sheet. You get to do each part separately. So for the e to the x, it was like number 6. But now for the polynomial part, kind of like number 3, but of 1 degree higher, you have to include all possibilities in the polynomial. So starting with cubed, excuse me, starting with the cubed power, bx cubed plus cx squared plus dx plus e. And then we make our comparison. So we compare, and we see that there's some duplications. And the a e to the x term matches the c5 e to the x, and we can get away with multiplying that just simply by x to the first. Then there will not be any duplications. But now this whole polynomial part, the highest power of x that we have in the complementary function is x cubed. So we have to avoid that in this portion of the solution. So just focus on the term of the constant term and ask yourself what power of x is going to be necessary to multiply this by, so that there are no duplications with the highest power of x here. See, x won't work because you got an x here. X squared won't work because you got an x squared here. X cubed won't work because we have an x cubed here. So therefore, we're going to have to multiply by x to the 4th. So finally, we take our y sub p to be equal to ax e to the x. And then I'm going to choose to distribute the x to the 4th, just multiply it by every term. So plus bx to the 7th, plus cx to the 6th, plus dx to the 5th, plus ex to the 4th. Okay, so a couple questions on those. That one in particular is kind of interesting. And so the next thing is an initial value problem. And where the method of undetermined coefficients is going to be required because it's a non-homogeneous. I'm deliberately showing you the examples of the types you're going to see on the exam. If you look back at the first two questions we solved, we found y sub p. There was an exponential and a trigonometric. And so, just to make sure I test you on everything, this one here has an algebraic. So this is a good problem for an initial value problem. So this is putting everything together. We have, remember, when you have a non-homogeneous, the solution y is made up of two parts, the complementary and the particular. And so for the complementary, form the associated homogeneous, y squared minus 9y, y double prime, minus 9y is 0. the characteristic equation. R squared minus 9 is 0. That factors, or you can isolate the R squared, but factoring, get R is 3, R is negative 3. So the complementary solution, y sub c, real distinct roots, so c1 e to the 3x plus c2 e to the negative 3x. And it doesn't make a difference what order they're in, if it's c1 e to the negative 3x plus c2 e to the 3x, that's fine as well. Okay, so then we're going to consider our guess for y sub p. And that is based on the function that this differential equation is equal to 18x squared plus 5. So it's a polynomial starting with the highest power being x squared. So ax squared plus bx plus c. Because remember, everything has to be included. We make a comparison, and there's no duplications. So that's nice because we don't have to multiply by x or anything like that. We could just jump right to the derivatives. So y sub p prime, 2ax plus b, y sub p double prime, 2a, and now we substitute. So we're in search of y sub p. Let me rewrite the given differential equation, y double prime minus 9y, 18x squared plus 5. You don't have to rewrite it. But substituting y double prime, 2a, and then minus 9 times y was ax squared plus bx plus c. That has to equal 18x squared plus 5. And so at that point, we could start comparisons. So compare the x squareds. And here we have negative 9 ax squared. And that's the only thing on the left, equaling 18x squared. So divide out the x squareds. Negative 9a is 18, and a is negative 2. Okay, let me compare the x's next. On the left, we have negative 9 bx equaling 0 x, because there aren't any x's on the right. So negative 9b equals 0 when we divide out the x's, and b is 0. And then we'll compare the reals. And on the left we have 2a minus 9c equaling, constant on the right is 5. And there's an equation with two unknowns, but not really, because we know a is negative 2. So 2 times negative 2 minus 9c is 5. So that's negative 4. So add 4 to both sides. Negative 9c is 9. And c is negative 1. So that comes out pretty. And y sub p then is back to what we guessed, and we didn't have to modify. A is negative 2, so negative 2x squared. B is 0, so no need to include the x. And then plus c, which is negative 1, or we'll just write minus 2x squared minus 1. Okay, so then the actual solution, once again, is the complementary plus the particular. So our y here is c1 e to the 3x plus c2 e to the negative 3x, and then plus the y sub p or let's just write minus 2x squared minus 1. Okay, and to solve for C1 and C2, we're going to need to use the two initial conditions that involve the function itself and its first derivative. So let's take the first derivative of this. Get 3c1 e to the 3x minus 3c2 e to the negative 3x, and then minus 4x. And now we can use the initial conditions. The first one, y of 0 is 3, gives us that 3 is equal to, okay, substituting in here into y, e to the 0x, so c1 plus c2. This term goes to 0, but don't lose that negative 1. And now for y prime of 0, that was 6. Again, the initial conditions are up here. And so therefore 6 equals, looks like 3c1 minus 3c2. Because the 0 in for x here gives us a 0. Alright, so solve the system any way you like. I'm going to bring the negative 1 to the left, so make that 4 equals c1 2. And then if I divide this bottom one by 3, we get 2 equals c1 minus c2. Add those two equations. The c2's are gone. 6 is equal to c1, 2 c1s. So therefore, C1 is 3. And then we back substitute to find C2. And use either equation. I'm going to go with the 4 equals C1 plus C2 equation. And C1 was 3. So C2 is 1. So then our solution, y, is now equal to, go back up here, c1 was 3, so 3 e to the 3x, and then plus c2 was 1, so plus 1 e to the negative 3x, or just plus e to the negative 3x, and then don't forget to tag along the minus 2x squared minus 1. Okay, let's see, we've got, next thing is variation of parameters, and that takes a little bit of time, so I'm going to cut this video short. We'll come back for part 3, probably even have a part 4, and maybe a part 5, but hopefully you're finding this as enjoyable as I am, and useful in preparation for the exam.